Let's start with our first panelist, Jim Maerzke. I'm not going to go through their whole bio because I know we're running short on time. He is the owner of Procubed, and he is going to be talking about the development of the 21st century wheelchair in collaboration with UW-Parkside.
Thank you. I'm very happy to be here today with my wife, Teresa, who I also drive crazy helping to run our business. She puts up with a lot. I'm a 1983 graduate of Parkside when they used to have an engineering program. And I have worked for a lot of different large companies like Bristol-Myers, Baxter, and a bunch of startups and entrepreneurial, mostly medical companies. And I discovered that I liked the smaller companies better, and I liked getting things done faster and having people's effort mean something. It sometimes gets lost in bigger organizations, which probably are a little political. Anyway, I stopped working for Baxter in the beginning of 2008, and we started a company that designs and builds machinery. That was Procubed's cash flow. And the reason for that is it's a bootstrap operation to allow us to have the resources, design capability, machining, building things, to develop the mechanisms to build a wheelchair, a new kind of wheelchair. So I'm going to go through this kind of quick because we don't have a lot of time, and that's kind of what engineers do anyway. It's sort of a logical progression of things. So here we go. What we're making is a platform technology that's a revolutionary linear to rotary motion conversion mechanism. We call it the LRM. The reason we're doing that is that motion conversion is important to a range of products. Things like bicycles, automobiles. The most common motion conversion mechanism that that's used and most of us are aware of if you look at a bicycle is a crank. Cranks are at the heart of these devices, but they also limit the efficiency of the device. So what Procubed's LRM mechanism is doing, this would be the how, it uses differential forces to convert any movement into rotation in a direction that you select. And that conversion is accomplished at a constant torque with automatic transmission or torque versus speed ratio changes built into the mechanism. Its usefulness is that it improves the efficiency, the performance of a range of devices, anything human powered or anything with an engine, internal combustion engine, things like that. Of course, the first product you may have seen out in the booth, the first product that we're designing with the LRM is a replacement to the 79-year-old manual wheelchair. The wheelchair we're all familiar with has been around since 1933. It's been a good long run, and it hasn't been replaced because it's really a very difficult design problem because you need immediate tactile response. If you think about it, everything's done through the user's hands, whereby they change direction. That's a clutching mechanism to drive. They brake with their hands. They let go to freewheel. Everything is through the hands, which is also why the people who actually use the wheelchair to get around hurt themselves. They have carpal tunnel issues and other stress-related injuries that affect their shoulders, arms, elbows. Anyway, so we got to get around that. The numbers are that worldwide there's 160 people, 1 out of 160 people need a wheelchair. For our first product, we're focusing on young disabled veterans because they're the most in need of a better mobility option. You can imagine if they were completely capable people one minute and not the next, that something that helped with their independence would be greatly appreciated. The process of how we got here is that Procubed was introduced to Dr. John and Wharf by David Lintz, some of you may know him, of WEN, W-E-N. And that has led to a grant, which the Weiss's grant certainly helps with our bootstrap operation because we've been able to spend more time on developing the wheelchair. What we're doing now, we've been running this program since June of 2010, and we've been able to put together a team at the University of Wisconsin-Parkside, and just a list of some of the things that that group is helping us to do is we're working on focus groups, publishing things about our methods of testing, design work, including very artistic things that have more to do with style than function that the users like, patent searches, contact development, testing, statistical analysis, developing contacts with the VA, the Veterans Administrations, for example. The outcome of all of this is going to be a better wheelchair for disabled veterans, a product with international need that will help people and bring positive attention to the UW system. We have currently 3 students and faculty that are working with us, so we're going to get, they get some significant experience. And we will be expanding employment as our wheelchair gets launched and develops market share. And the LRM technology is, of course, a platform technology will apply to other products. So in conclusion, we have been working together with UW-Parkside, and that has really had some very positive effects that very soon we will be introducing a new product. That's it. Thank you.